processed this kind of information that scientists had.
You know, I love telling people you can go outside on a sunny day here in Southern California, we have plenty of those, and you can actually feel where the sun is in the sky. You know, our heat sensors on our skin are sensitive enough to feel the sun. And then you say, what we're trying to do is literally feel the heat from a galaxy on the other side of the universe.
So this data comes in, and then the scientists have to kind of make an analogical relationship between the data and something we could see visually. So they have to kind of compress it into visual colors and then represent it so we get to look at it. Well, that's just a big translation right there. And that's, from my vantage point, a lot of my work is about the kind of the awkwardness of communication.
I've learned a lot, and one of the things I've learned is that space is endless. Even though it is finite, it seems to be endless. And so no matter how much data has been collected with this telescope in the last 6 years, there's still endless amounts of space.
And through the research that Spitzer is doing, it just feels that I can sense myself way out in time-space. So that's the inspiration.
It's just really fascinating to look at something that everything is at a different point in time, and it's not now, it's in the past.
I think it's intriguing that it's titled Observe, because that is what I believe artists and scientists share.
It's also revolutionary, and it has so much impact. It's not just about seeing something that explodes in the cosmos or exploded 400 years ago. It's the fact that we can see something that happened 400 years ago, and that we're looking into the past, and that there might be multiple dimensions surrounding us that we can't sense. And the fact that the camera sees in the infrared, which is a non-visible spectrum, so it sees things that we can't see. And all of that's very interesting to artists, and a lot of that came out in those conversations.
The image will be projected on the right side, and you can see this image, and you can see that it has curves in it, and basically I'm using a panoramic stitching software that was developed by a PhD student. Okay,
I was just saying that you probably have some leeway as an artist depending on the projection of the sky that you use. You know, your image of the whole sky. Using different projections will get the laser to follow different paths and different shapes. So you can probably choose which one you think is a more artistically interesting. You know, we can sort of provide you with different projections you'll be able to use.
So we can go look at this star and say, at this phase of its life, it looks like it's doing this. And then we can go over here and look at this star, and it looks different, right? And we can say, oh, that's at a different phase of its life.
Yes. And I'm really, really excited about this collaboration in that, I mean, all of you, every time I've come here at all the meetings, there's such great energy. And looking at the kind of work that you do is just so amazing, so important.
And our main mission is even ramping down. It's one of the reasons why we really want to feature the incredible science we've done. There's so many varied things that Spitzer does. It looks at the universe in heat light, in infrared light, so it's not a wavelength we see at all. So one of the most wonderful things about our images is that anything you see from a telescope is not the way a human eye would see it. Most of the things are entirely invisible to the human eye. So we look at everything from it's particularly good at watching stars and planets be born, because they're born inside these giant clouds of dust and gas that are so thick we can't see through them. All the light is absorbed. So it's a wonderful instrument for actually witnessing the moment of the birth of a star and of solar systems.
How do you find a metaphor to describe what it's like for our brains to grasp the idea of an infinite number of dimensions?
Right. You know, I mean, the brain of an ant is an incredible thing. It has no idea what Michelangelo is, what a cathedral is, what a particle collider is. You know, we are probably at a similar state of evolution where we just simply can't understand now some of the things we're starting to observe. I mean, we watch an ant crawling a particle collider, you can say, okay, we're in the same place. The ant is somewhat aware of the particle collider, but, you know, we have another leap probably to understand what the universe is now presenting us with. Our human brains just aren't going to do it. And that's where metaphor and the power of observation come together, so we can start exploring this new realm.
How to place oneself, like each individual being, in relationship to, let's say, the stars, so that if let's say there's an object right in front of you, and you know that it's placed there to be in alignment to a particular star above at a particular time, that connects you, it gives you a sense of connection to the motion that our planet is going through, that our solar system is going through.
We're more like anthropologists than we are like any of the other hard sciences, because they essentially are looking at data and trying to extrapolate some theories based on, trends within the data. They can't do any tests. They can't do any. They don't have control groups. They can't actually alter the data to find out what that does to things. So in a way, they're just looking at this data and trying to figure it out. And in a way, that's kind of what an artist does as well. You have an idea, you look at this data, and you try to, or vice versa. You look at the world, which we could consider data, and then try to extrapolate some either theory or something that would jar the theories that we have about the world, and then present that.
This particular piece, I'm going to have a whole bunch of discs that look like it's a clock when you first walk in, but it's going to look like a flat clock. But as you actually walk into the space, you realize that all these pieces of the clock are different distances away, and it becomes sort of like an exploded clock, a really crazy clock. And there's an audio component where when you speak into it, there's a time delay of when you actually hear.
They're all interested in these places where science and philosophy and perception overlap and challenge each other and can come in conflict. Some of the artists are dealing with time. Other of the artists are dealing with data. What does it mean to extract data from the universe, and how does that data get organized? And could it be organized in a different way? And if it were organized in a different way, would we have a completely different opinion of what the data tells us? So they're interested in how data gets interpreted.
Well, as an artist, I have addressed issues with science in various respects in the past, and not so much in a way that's a replication of how science works, but more as sort of in awe of the knowledge that one acquires from science.
approach what they do through reason, and artists approach what they do through sort of intuition. And I think, in fact, they both work in those worlds. I mean, scientists do use intuition a lot. They have hunches. They go on those hunches. And vice versa, I think artists deal a lot with reason and logic in their work. But it is this ancient dualism, you know, this art and science is what we now call left brain, right brain, but the conversation between intuition and reason.
So perception versus reality. Reality is just a slippery concept in general, and they would be the first ones to say that that's the case.
Anything that can happen